Okay, here we want to find the center and radius of this circle. Now this circle is not in the format we like. If you recall, the format we like for a circle is x minus h squared plus y minus k squared equals radius squared. So that's the format we like. We're not there. How do we get there? Well, what we need to do is start by grouping the x's and y's together. So I'm first of all going to write this as x squared plus 4x. Then I'm going to put the y squared minus 6y. And then I'm going to add 3 to both sides. And so that negative 3, when we move it over, becomes a positive 3. Now, how do you complete the square? Well, you take half of 4, which is 2, and you square it. For y's, we take half of 6, which is negative 3, and we square it. Now remember, we added 2 squared on the left, we need to add it on the right. We added negative 3 squared on the left, we need to add it on the right. So all I'm going to do is simplify the 2 squared to 4. I'm going to simplify the negative 3 squared. Now negative 3 times negative 3 is positive 9. So the right becomes 3 plus 4 plus 9. Now when I factor this, we need to think of two numbers that multiply to 4 and add to 4. And of course those two numbers are 2 and 2. If you completed the square correctly, these two factors better be the same. If they're not, you know you didn't complete the square correctly. For this one, we are looking for two numbers that multiply to 9, add to negative 6. So negative 3 and negative 3. Again, notice they are the same. If they were not, then we knew we had a problem. Now, this is called completing the square because the factors are the same. We can write that as x plus 2 squared. We can write this as y minus 3 squared. And now we have the format we were looking for. Now remember, the reason we like this format is because it tells us the center is going to be h and k, and it tells us the radius is going to be r. So comparing these, we see our center. We have x plus 2, which is x minus negative 2. So really you're just taking the opposite of what is written there. And we have y minus 3, so the y value of the center is positive 3. Notice the right-hand side is r squared, so we need to take the square root of 16 to get the radius. In this case, we only want the positive square root because it is, of course, a distance. And with distances, we need to have positive distances. So what I'm going to do to graph this circle, that's my last step, I'm going to go to negative 2, 3. Dang it, let me make that slightly bigger. Let's try that again. Negative 2, 3. Still not very big. Oh well. I'm going to go up 4 units. Oh, holy cow. Sorry. I'm going to go right 4 units. I don't know how that got so big that time. I don't know. Oh well. Down 4 units and left 4 units. That's not very pretty. Oh well. Close enough. And then I'm going to connect those with a circle. Now I have this little circle thing. Oh, look how nice that looks. Okay, so I connected those 4 points. It actually looks beautiful because the program lets me draw a circle nicely. Didn't do it by hand, so there we go for our circle. Okay, now in the next problem we want to decide whether or not we have a function. For this first one, I'm going to say the answer is, oh, dang it, sorry. Don't want to draw a circle, I want to answer the question. I'm going to say the answer to whether or not we have a circle is no. Why is that the case? Because we have to explain why not. Well, look at these 2 points. What do you notice about those 2 points? They have the same x value, but different y values. So the reason it's not a circle is 2 points have the same x value, but different y values. And that is not allowed with a function. With a function, each x value is only allowed to be paired with one y value. Okay, now what I want to do here is I want to look at the second one. I gave you a graph. Now the way we can tell if a graph is one-to-one is we can do the vertical line test. So let me just draw a handful of vertical lines here. Okay, on accident I paused the recording. I don't know where I paused it at, so rather than start again, I'm just going to maybe repeat what I just said. So for this second one, we have a graph. I drew 3 possible vertical lines, and if you notice, none of them ever intersect the graph in more than one point. So what that tells me is it passes the vertical line test. So yes, this happens to be a function. Okay, now let's look at the last one. For this one, I gave you an equation. When you're given an equation, we need to decide for this equation, if we pick one x value, how many y values does it get paired with, or does it get mapped to? So I'm going to start by solving this equation for y. So I subtracted 2x, and now I'm dividing by -3. Don't forget, when you divide by -3, it's going to change the signs. Notice these two negatives make that a positive 2/3 x. Positive 6 divided by -3 is -2. So I solved for y. Now I want to see what happens when I pick an x value. So I'm going to pick a nice x value. I'm going to pick 3. When I pick 3, I plug in 3 for x, and let's see what comes out. Now I purposely picked 3 so that those 3's would cancel. So I'm left with 2 minus 2, which is 0. So notice for each x value, and I didn't check every single x value, but you can see that when you pick one x value, you are clearly only going to get one y value out of it. When do we not have a function? Well, notice we talked about in class if the y were squared. If the y were squared, when we solved for y, we would take the square root of both sides, but that would include the positive root and the negative root, in which case we would not have a function. So y squared is what you're looking for when you don't have a function. Since ours doesn't have a y squared, it does happen to be a function. Okay, here's a function. We just want to evaluate this function. So I'm going to do it the safe way. I'm going to let's change that to black. Okay, so I'm going to rewrite the function with an empty set of parentheses everywhere I see an x. And if I do this, I can then just go back and put in a -2 everywhere it needs to be. I guarantee this is the safe way to do it so you get the right answer. When I cube -2, -2 times -2 is +4. +4 times -2 is -8. When I square -2, -2 times -2 is +4. So what I'm ending up with here is -8 over -5. And we would always want to simplify our answers, so the simplified answer is +8/5. I don't know if I need to write that up here on this line or not. Okay, almost the same question. So once again, before I do this, I'm going to write the function with an empty set of parentheses. And now when I do this, I feel confident that I'm going to get it correct. So now what I'm being told to put in these parentheses is 2x. Okay, when I cube 2x, I have to cube the 2, which is 8, and we have to cube the x, which is x cubed. When I square 2x, I have to square the 2, and I have to square the x. So it looks like this is what I'm ending up with. So this is a little bit more complicated. I'll go ahead and put the answer in here. I have 8x cubed over 4x squared minus 9. That is my function when the input is 2x. Now, for this, just so we recall what's happening here, here's my original function. Whoops. x squared minus 9. The other thing I want to write down is what the opposite of my original function is. Now this is tricky because of the fraction. Remember, with fractions you can put the minus in front, or I could put the minus on top, or I could even put the minus on bottom. Now if you're going to put the negative on, I should say negative, not minus. If I'm going to put the negative on bottom, I could put it in front with parentheses, or I could choose to distribute it through and write it as negative x squared plus 9. So notice with a fraction, putting a negative or multiplying a function by -1 becomes a little bit more complicated. Okay, to test for even or odd, the test is this. If f of negative x is equal to f of x, then our function is even. On the other hand, if f of negative x is the opposite of f of x, the original function, our function is odd. And of course, if neither of those is true, the function is neither even nor odd. So we need to find f of negative x. So following my hard and fast rule, I'm going to write out the function. Everywhere there's an x, I'm going to put an empty set of parentheses. Now I can go back and replace each of these with negative x. You do need to simplify. When you cube a negative, it stays negative. When you square a negative, it becomes positive. Now if you notice, if you go back over here and look where I wrote down f of negative x, or excuse me, the opposite of f of x, it looks exactly like this one. So what we've ended up with here is the opposite of f of x. So what I have just shown is that this function is odd. Okay. You know what, this video is getting kind of long, so I think I will save this for the next one.